Brilliant. Thank you. I know you will load everything afterwards. Thank you, colleagues, and enjoy.
Thank you, everyone, for the introduction, Sasha. Thank you, everyone else. I think we don't really have much more time to go around the room. We're just killing time to get people to come in. So most of you appear to be doctoral students at proposal stage. And what we're going to cover is quite important. Even though SPSS, you're actually going to do the analysis later, your research instrument needs to be set up in such a way that you are able to perform the statistical tests that you need. By the way, just for record keeping, I am recording this session simply because it's going to be very important for you to come back and forth to this. Even when I do very complex stats, I have a whole series of videos which I literally watch, and they take me through step by step how to do things. So I'm going to hide my face now. I wonder who in the room. I'm going to continually check that you can see the screen. That you can see the screen when I share. So who can I ask? Can I ask Shiba each time I go to a screen? I'll just ask you, can you see the screen? Okay, is that okay?
Okay, no, it's fine. It's fine. I will do that for you, Prof.
Perfect. Thank you so much. So this presentation is divided into two parts. The one I'm literally going to spend 5 minutes on, which is actually just some theory behind quantitative analysis. And then the other part is actually taking you through SPSS and showing you how to load your questionnaires, capture your data, and do statistical analysis. So I can tell you now that this session won't finish at 6:30. It'll probably finish at 7, I guess. So if you need to leave early, that's not a problem. It has been recorded, and I'll upload all this material on Blackboard. And there are previous years' YouTube links, and so you can also watch those videos as well as this year's video, but it's more or less the same, although not the same. So let's go to the PowerPoint presentation, which I'm going to go through very quickly so we get to the rest of it. Shiba, can you see on your screen quantitative data analysis? And it's like a PowerPoint screen. Or anyone else, can you see that a PowerPoint on your screen saying quantitative data collection? There should be a you can see it.
Yes, you can see.
Okay, perfect. Thank you very much. So my name's Rodney Duffett. I'm in the marketing department where I'm the research coordinator, also in the Faculty of Business and Management Sciences. If you want to look at my research, ResearchGate, Google Scholar, ORCID ID, my email address is here as well. So what is data collection firstly? Well, it's the systematic gathering of information on a specific subject, which can be obtained directly from original source, which is primary data collection, which all of you will do in some or other format for your research. And some of you may be qualitative. Most of you, I assume, are quantitative because this is what the presentation is about. Some of you may be a mixed method. So secondary data is obviously the data that has already been collected. So your journal articles, your books, your survey results, these other theses. So that's what you're busy with now in your research proposal. You're using secondary data to write that. And basically, you're collecting data to validate or disprove your research questions, objectives, and hypotheses. Just some differences between qualitative and quantitative. So I'll mainly focus on the quantitative. You can look at this afterwards. So it's precise and it gives results in numerical formats, which I'll be showing you how to do a bunch of statistical tests. It's structured, defined. It's how much, how many, how often, whereas your qualitative is more your how and your why. It's large groups of participants, mostly closed-ended questions, because if it's open-ended, then it's going to result in qualitative. It's precise numbers, it's counted, it's measured, it's questionnaires and tools, often very difficult to develop, but easy to collect and analyze your data once you've got it. Qualitative instruments are usually easy to develop, but your data is difficult to analyze because it's very subjective, whereas quantitative is more objective. It indicates specific measurable and numerical results. It's objective, it's conclusive. The analysis of rules are well established, as you will see. So data collection factors. So you may want to answer specific hypothesis or research questions. So we will cover that in my SPSS present later. Different types of data. So we're focusing on quantitative. You need to determine how many respondents as well. We'll talk a bit about that. It usually needs to collect it within a time frame. You've got cross-sectional, which happens at one point of time, and longitudinal over an extended period of time. There are various data collection methods, from telephonic to online to face-to-face. And this, obviously, all of the data collection above depends on your costs and your budget, how much it costs. These days, though, with online, it doesn't need to cost you anything to collect data. If you can create a Google form, disseminate it, it costs you nothing. So quantitative measures behaviors, attitudes, and opinions. So most of you will probably be measuring some type of behavior or attitude amongst individuals or amongst maybe small businesses or businesses to support or reject a hypothesis or a premise, such as a research question or objective. It gathers numerical data, as we said. It's quantifiable, and you want to usually determine the statistical significance. And often I come across theses where there's absolutely no statistical significance. They've just used descriptive stats, and descriptive stats do not mean anything. You can use pretty graphs, but you cannot generalize anything. So that is what I'm going to show you tonight, how to determine statistical significance later. Results, you use numerical values such as mean, standard deviations, frequencies, and a whole bunch of other measures, which we'll do later on tonight. You need to ensure that you have an appropriate sample size as well, so it can be extrapolated on the larger population. Although I'm not going into sampling, but if you're using a non-probability sampling technique such as convenience sampling, snowball sampling, or quota sampling, in any event, you can't generalize it to the larger population, but you can still determine statistical significance, which means a lot more than descriptive stats. Quantitative data importance, so it's more objective and precise. It quantifies, as I say, particular problems and theories. You can gain insights from extensive samples. You can also get data is more feasible, and you can also segment the data into smaller subsegments. So you can do cross-tabulation between age and gender and other usage characteristics, which can provide very interesting results. We'll have a look at a bit of this tonight. And then just the major methods, I'm not really going to spend much time, but the most common method is a survey where you either conducted face-to-face, telephone, paper-based, computer, online, using social media, QR codes, WhatsApp. It's the most common way, a questionnaire. And here's a whole list of design tips, but I'm not going to go through them now because I want to get to the SPSS. Survey developmental questions, so who is the demographic, so who you're trying to access, that you need to consider. Which questions were you asked, so what is the actual information you need to know, and the nice to know, because a questionnaire that's too long will not be completed by participants or by all of them, so you really need to keep it concise. How will you reduce bias? So how, you need control measures, you need to measure reliability and validity, which is also lacking from most students. Research don't know what reliability and validity is. Some of them just make up their own questions, and you should not be doing that. It should come from somewhere. What is the questionnaires length? What is the best way to disseminate it? And do you require an incentive to participate? Sometimes you need to give an incentive. Even if it's walking around campus and you're doing face-to-face and you're giving a student a suite to complete. If it completes it, that's one more questionnaire that you've done. Different types of survey questions. So you have closed-ended, which is preferable because it's easy to do statistical analysis and interpretation through graphs, tables, numbers, and charts. You should have a filter question to filter out people that don't meet the requirements. So if you are studying Gen Z, so Gen Z's born between 1997 and 2010, any person that's not born in that period should not pass the interview. And say, in my instance, I focus a lot on digital media, and say you're looking at Instagram influencers. If they don't have an Instagram account and they don't follow anyone on Instagram, then again, they won't be able to complete your question. So the filter question should filter those people out. multiple choice questions for mainly your usage and demographic factors. Scales and Likert scales are vital. Most of you measure attitudes, and those Likert scales need to be taken from existing research and adapted to yours. You can't just make them up. And there's some questionnaire examples, but I'm not going to show you those now. I will show you one when we do the SPSS, a very basic example of a questionnaire. Also, a pre-test versus pilot test. So a pre-test, once you've finished your questionnaire, you could submit it to 10 people to check the wording, the layout, and the clarity, whereas a pilot test tests the whole research process. So in other words, from your sampling to your questionnaire to your data collection, and even doing a preliminary analysis to see that the results are meaningful. So you could do a pre-test amongst 10 people to check that your people understand the questionnaire. There's no wording or problems. You could even give it to lecturers and other people just to have a quick look, but preferably your target market, and see what the problems are. And a pilot study is larger, maybe 30 to 50 participants from your actual research population, taking it through all the different processes. So depending if you're doing a big study, it's good to do a pre and pilot test, so that you don't run into a problem after you've collected a couple of hundred questionnaires. And then I'm not going through the rest. There's interviews, there's observation, there's document review, there's experiments, and those are the references. So that was, the quantitative data collection, the overview. Just any questions at this stage? Or you're all good? Hi, Llewellyn, good to see you as well. Go get Roderick.
Prof, just a question with regards to the pre-test and the pilot test. Is it a
Yes.
must to, when does it become a must to do the pre-test, or can I just go straight into the pilot test?
You can go straight in the pilot. The pilot serves the same purpose. It's just more extensive, the pilot. So you check in other aspects of your research process besides the questionnaire. So yep, you can definitely go straight into the pilot. It's not a must to do a pre-test.
Thank you very much.
Okay, great. So now we're going to, if there's no further questions, now we're going into the nitty gritty, and I'm going to be bouncing back and forth through a lot of screens. So I will ask whoever, or maybe I see Shiba's out the meeting, so I'll ask Roderick each time if he can see the screen. So let's go to the actual nitty gritty, and these notes will be available. Roderick, just to check that you can see the screen, Word documents open called quantitative data.
Yes,
You
Prof.
can. Okay, great. So here's the actual notes that I will place on Blackboard after the session so that you have them. And here's a YouTube link from last year already. So if you click on this, you'll be able to get these notes. I may even, well, yeah, I don't know if I'll bother putting it on YouTube again, but there's last year's link in any event, and this video will go on Blackboard. So now we're going to look at SPSS, and this is how to do your data analysis, but it starts earlier than that. It starts with your research questions and your objectives and your research instruments, which you're all busy with now at proposal stage. So just in terms of statistical analysis, my philosophy is you learn different measures to find the answer to the research problems and questions at hand. And then you expand your knowledge as you need to know further statistical tests. And this is the approach I've taken with my students. As students have different needs, so I've expanded my knowledge to be able to do and perform the different tests they need to, to get the data that they need. So you don't need to become a scholar and go through like an 800-page textbook, because that's how long they are. Like Andy Field's textbook is that long. Refer to the resources section. But I rely heavily on a real guru in stats, Prof. James Gaskin, and he has a website and a YouTube channel, so I've just placed them there. And as I need to know specific things, he really explains things in a simplistic manner. Then I've downloaded actually the videos, a whole lot of videos from him, not for this, but more advanced statistics. And to this day, when I do stats, I literally watch those videos because I don't do stats every single day. You know, I maybe do my student stats 3 or 4 times a year, and maybe another 3 or 4 times for journal articles, but that's it. So it's once every 2 months or once a month. So, you know, you'll forget very quickly little steps. So he's very good, and yeah, YouTube is not just him. I mean, anything you want to do, you just Google it, go to YouTube, and you'll be able to find someone to show you how to do a certain test. So the majority of research aims to resolve certain gaps, knowledge gaps. And so I'm giving you an example from one of my students who finished a thesis about 5 years ago. And I've used her questionnaire and her research questions and hypothesis, just a very simple questionnaire, to take you through SPSS and the questionnaire and data caption and all of that. So her research focused on social media as a communication and marketing tool amongst Cape Town tourist attractions, and she was looking at 3 constructs: cognitive, affective, and behavioral, which is known as the CAB attitudinal responses. And she wanted to look at the influence of various geographic, social media usage, and demographic factors. So, you know, in order to address the research problem, in her case, there was a need for further research amongst these different tourist attractions to see how they view social media. And so her research questions were: what influence does region have on tourists who arrive based on their CAB attitudes due to social media usage as a marketing communication tool? How do consumers' attitudes differ across the various tourist attractions? How do CAB attitudes differ across different platforms? What influence do social media usage variables, so this is access and login frequency, have on the CAB attitudes? And what influence do demographic factors have on CAB attitudes, which is gender and age? So we're going to answer these research questions statistically. And so all of these research questions should be included in your questionnaire in some other format, and we'll have a look at a questionnaire now. So your research questions basically, or you develop your questionnaire based on the research questions, or if you've developed your questionnaire, your research questions come from your questionnaire. You can look at it from both perspectives. Some people come up with the questions first, others develop the questionnaire, and then from the questionnaire it's easy to develop your research questions. The hypothesis that she wants to test is just a very, very simple model. She's saying cognitive attitudes have a positive effect on affective attitudes due to social media marketing communications amongst tourists in Cape Town. And then, so that's cognitive, have a positive on affective. So this is 1. She's saying cognitive has a positive effect on behavioral, and affective has a positive effect on behavioral. So that's a model. 3 hypotheses. Most quantitative research should have a few hypotheses if you've got 3 or more variables, all research. And that's a conceptual model, and this was developed from the theoretical framework of CAB, as it's commonly called. Okay. So before we go to questionnaire cleaning, let's just go to her actual questionnaire, and you'll see that all those research questions and the research questions and hypothesis will be captured in this questionnaire. Just to check, Rodrigue, that you can see the questionnaire called Cape Town Tourist Attraction Social Media Questionnaire.
Can see, Prof.
Okay, perfect. So her first research question was, is there a difference between regions in terms of CAB? And so here she's got a question, which region do you reside in? So this we can cross-tabulate with CAB, and it would then give us that answer. Not to say that each research question could be, you could have 5 questions in the questionnaire, and they answer 1 research question. So it's not like it's 1, 1, 1, that the same questions you have, it's different. The research questions are much broader and cover, a broader scope, as you'll see. But in this instance, just to simplify it, I've done a few 1, 1, 1. So that the next research question was, is there a difference in different social media sites? So here people need to select which social site they've been exposed to the most. in terms of the Cape Town tourist attractions, and these are the big 5 in the Cape Town tourist, is Table Mountain, Cape Point, Victoria, Kirstenbosch, and Grootfontein. You may be wondering why Robben Island isn't here. Well, when she did this research, Robben Island didn't have social media. So if they do have now, at that stage, they did not. So that's why Robben Island is not here, but these were the big 5 that did have a social media presence at the time she did this research, which was about 10 years ago. And so that was a second research question, but you can see this is going to give the answers. The third research question was, which social media have you used to access the Cape Town? So Facebook, Twitter, and YouTube. At the time, these were the big 3. Now there's others. There's well, it depends what sites the tourist attractions had. So it wasn't that you were going to list all the sites, and back then Twitter was called Twitter, now it's called X. Back then the sites weren't on Instagram, they weren't on TikTok, they weren't on Snapchat, they weren't on them. So just bear in mind this questionnaire is about 10 years old. So these were the 3 sites that these tourist attractions used at the time of this research. Then she's given her Likert scales. She used a 4-point strongly agree, disagree, agree, strongly agree, but now definitely I make my students use a 5-point or 7-point. We wanted to force them in a direction, but people generally don't use 4-point Likert scales. Generally you have a neutral in the middle, or you can do a 7-point. So you have strongly disagree, disagree, somewhat disagree, neutral, somewhat agree, agree, strongly agree, or somewhat agree, agree, strongly agree. You can have a 7-point, or you can have a 5-point. Most people use a 5-point, so I wouldn't go the 4-point route, but in this instance, she used a 4-point. Where do you get these Likert scale questions? So the first 6, you could actually put the heading here, cognitive attitudes, above, and then the 6 statements. These statements were taken from existing research. So she didn't just make them up. So she found other research that considered cognitive, tried to go to the original source that formulated this construct. And so she adapted their statements to match her topic, which is tourist attraction and social media, because often when you take constructs, the original authors aren't looking at the exact same topic as what you are looking at. So therefore, when they developed this cognitive scale, social media didn't even exist. So you are just adapting their essence of their questions to your topic. And then the next 6 were affective attitudes, which deals with your feelings. And again, she would have taken this from 1 or maybe 2 sources and adapted it to a topic. And then the last 6 have to do with behavioral attitudes. And again, they would have been taken from a source, and you would in-text reference that in your research methodology, in your research proposal. You could say that, well, she would have said the cognitive scales, we measure in CAB, the cognitive scales were taken from this research and that research, the affective scale was taken from this research, and the behavioral was taken from that research. So very important that you don't make up these. They must come from articles, and preferably you need to find the original source. So see who everyone else is citing. And if you know what theoretical model you're using, then you need to go and search for who created that theoretical model and find the scales that they used. It's best not to take other people that have already adapted the original Likert scale items, and they've adapted it, and then someone else has adapted it. It's best to go to the original theory. So to go to the original CAB and see what, and for these scales, people would have cited them thousands of times already. So when you find those sources which have been cited thousands of times, you found the right source to get the original scale items from. I will pop back into the room now, and then the fourth research question. So these questions are for your hypothesis. So these are your 3 constructs, but we need to do factor analysis to reduce this into the 3 constructs. So we will, you don't decide that, the statistics decide that. Then how do you mostly access? So these questions 5 and 6 answer your fourth research question, which was, do usage factors have a influence on your CAB attitudes? So it's how do you mostly access and how often do you log on? So both these questions are asking your fourth research question, and your fifth research question was, do demographic factors have an influence on CAB? And demographics in this is gender and age. So you do cross tabulations with these elements. So I'm going to close this quickly, close this current tab. We'll leave this open for later, and then I'm going to pop back into the grim. Do you have any questions regarding specifically your design of your questionnaire in terms of the construct? So some of you said you're measuring this construct or scale or this item or that item. Any questions regarding that? I just want to emphasize it's very important that that's the most important part of that questionnaire were those 18 items that measured those 3 constructs. You must get that as far as possible from the original source. Because then that will help your reliability and validity. You cannot make it up, and don't just take the most recent source who cited someone, and that person who they cited someone, and you're going back 5 or 6 articles before you get to the original source. So that's why it's very important to select your theoretical model, and from there you can develop your conceptual framework. So a theoretical model is the original theory, and from that model, or you can take 2 theoretical frameworks and combine them, then you are looking at new relations in relation to a different target audience and maybe a completely different topic. And that's how you add to knowledge. So taking existing frameworks and applying it to different fields and different respondents. You're all happy, clear on that? And that's important in your proposal because already you see if you have developed your research instrument correctly, that shapes your research questions, your objectives, and your hypothesis. Or you can come up with the hypothesis and research questions and then develop your questionnaire accordingly. Some of my students end up having their questionnaire before that, and then it's so easy to work out the research questions and hypothesis afterwards. But generally, it's done. You first come up with the research questions and hypothesis, and then you develop your questionnaire. Okay, so that's just, let's go back. Let's dive back in. So then you need to collect your data, and then you need to clean your data to check that there's no missing data. You need to then code the questions, and if you're not collecting, so let's just show you a few things. So data capturing. So how do we capture this questionnaire? Well, each question, I always tell my students, do it in Excel first, and then later you can set up the SPSS. So very important is to, in this column, just to check that you can see this, you can see an Excel spreadsheet open with a bunch of numbers. Someone? Can you see an Excel spreadsheet yet?
Yes, I can.
Okay, you can. Perfect. Thank you. Thank you, Llewellyn. So if we just go back to this questionnaire, we need to code this questionnaire. And the reason we're coding it is because we're going to copy this data eventually into SPSS, which is going to do all our statistical analysis for us. So the first question, and so let's just say you did a couple of 100 questionnaires. Which region do you reside in? Then you need to code it. So South Africa would be 1, Africa would be captured by 2, and international captured by 3. So in the questionnaire, in this this capture, you would have questionnaire number, and then it's very important because I will show you why later. And then you capture questionnaires from left to right. So in this example, if they said South Africa for questionnaire 1, let's just put this like this, you would capture that by a 1. Right. Then if we go back to this data capturing, which of the following Cape Town tourist attraction social media have you been exposed to the most? So again, you code Cape Town 1, Victoria, Cape Town Air, Cableway 1, BNA Waterfront 2, Groot Constantia 3, Cape Point 4, Kirstenbosch 5, and others 6. So if they ticked Kirstenbosch over here, you know you would capture Kirstenbosch, or no, they clicked, I think it was a 4, they clicked Cape Town, Cape Point Nature Reserve. In this instance, then in here you would capture it with a 4. Then the social media sites, if we have a look, Facebook's 1, Twitter's 2, YouTube's 3, 4's others. So generally you code from left to right. Okay, so if they clicked 1, then for the first questionnaire you would capture it by means of a 1. Then the Likert scale questions, if you did manual questions and they've tick, 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 it's hard to capture this in your Excel sheet if you don't first code it. So I suggest if they click 3, write 3 there. If they click 3 again, write 3 there. If they click 1, write 1 there. So write it next to it, so that when you then capture it, you've already got the code, because it's difficult looking, and if you have a 7-point scale, it's even more difficult. So once you've got the questionnaires, write the codes down there, and then when you go to the Excel, it's quite easy. So they ticked agree, agree, agree. So you just capture 3, 3, 3. So all of these people clicked agree. So you just capture the first questionnaire, 3, 3, 3, 3. Then they click strongly agree, strongly agree. So you click 4, 4, 4. So that they either agreed or strongly agreed. So you capture them like that. And then you capture the last few elements, which is how do you mostly access it? 1 PC, 2 laptop, 3 tablet, 4 mobile phone, 5 other device. In this instance, they used was a 3, so a 3 is a tablet. Log on frequency. So in this instance, their log on frequency was multiple times a day, so you captured by 1, whether male or female. In this instance, we had given a 2, so they're female, and the age, again, we have coded 1 for 18 to 25, 2 to 26, 35, and you had captured this with a 3, so they were 36 to 45, and therefore you would put a 3 in there, and then you've captured your first questionnaire, right? And so you would need to capture all your questionnaires like this. If you have collected your data by Google Forms, what you can do is you can export the data, and then you can use find and replace. So Google Forms would save this as, they would say, this is South Africa, this is Cape Point, this is Facebook. That's how it would do. It would say this is agree, 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 agree. So in this, you could just say find and replace agree with 3. But you see, because you got strongly agree, don't find and replace agree first. First go to strongly agree, because otherwise you're going to have strongly 3, because it's going to replace the agree of it. So first go to strongly agree and replace all with a 4. Then you can go to, again, don't go to agree, because of the disagree, it's going to replace the agree part. So then go to your strongly disagree and replace it with a 1, and then you go to your disagree and replace it with a 2, and then you do your agree last word, because agrees in all 4 of the words. You'll quickly figure that out, and then it would code it all for you. So if you've done Google Forms, you can just use a find and replace to do the codes. Once you've captured all your questionnaires, so in this instance there was 384, which is the magical number in terms of statistical analysis. If you go to these statistical programs, it will say that it will never give you a sample size of bigger than 384, oddly enough. Once you've captured all your questionnaires by these codes, then you need to just check that there's no mistakes. If you've done it by Google Forms, you're fine. There won't be. But if you've manually captured, like for example, here you may have accidentally typed a 5. Here may be a gap. Here you may have accidentally put a comma like that. That's going to mess it up. And here you may have captured a 2, and there's no such code. So once you've done, I just say put your cursor there, click sort, and go A to Z. There's nothing here, but you scroll all the way down to the end. Is there a problem? Then you can say, yes, there is a problem with this, is maybe not captured right. Questionnaire 4, there's a little comma there, it shouldn't be there, so enter, not going to be a problem. Then you go to the next column and you go sort A to Z. There's no problems here. Scroll down all the way to the bottom and you see here's a problem. There's no code for 22. If you put that into SPSS, you wouldn't have programmed it to deal with the 22, so it's going to give you an error. It's going to capture 22 as a separate variable. So you need to go and check questionnaire 6. Oh, that should be a 2. And then there's a gap, so you need to go and check questionnaire 5. What did they tick there and fill it out, whatever it was, a 3 or whatever. Then you go to the next column and you go sort A to Z. That's all good. Scroll down to the bottom. That will show if there's any problems. And there's a 5, but there's no code for a 5 in questionnaire 3. If you go in question 3, it only goes up to 4. So if you have a 5, when you put this in SPSS, it's going to capture a 5 as a 5. It's not going to show Facebook, Twitter, or other. So, all right, let's go. So therefore, you need to check and say, oh, this was supposed to be a 1. And so you fix the you do this. Right. Let's just undo all of this stuff. Okay. Just make it a bit bigger. Right. So here I says there should not be any gaps. Check each column by data sort column ascending. This will show if you've captured 22 instead of 8 or 5, or if there's gaps. Once you've corrected the errors, simply sort it back into A to Z. So, you know, if you've sorted a column like this and you've gone sort, but never block it like that and sort, because it means it's only going to sort that column and it's going to take it out of sync. You just put it will say, do you only want to sort this column? And the answer is no. So always maybe save your data before you correct it, before you start correcting, because just in case you do something wrong. And you sort A to Z, and once you've finished with the caption, then you go to quest number and you go sort A to Z, and it puts it back in the correct order. That's why you number the questionnaires. And also, if you've captured them manually, write 1, 2, 3, 4, 4 on the questionnaire, so that if there's a problem, you can go to that questionnaire. If it's all via Google form, then it's fine. You can still capture it 1, 2, 3, because it will also list them in an order, and then it's easy to correct your mistakes. So yeah, and then yeah, you sort it back. So once you've corrected your errors, okay, we can get rid of that. This we'll leave now. Let's go to the next step. This is just the donkey work before we get to the fun part. So first, check that there's no missing data. So when you set up your Google form, make quite sure that you force a response. In other words, they cannot proceed to the next question until they've clicked on an item. So very important when you set up your Google form, because you don't want missing data, because if there's too much missing data from a questionnaire, then you can chuck it away. You have to do another one. Secondly, code the questions. We've done that. Thirdly, write 1, 2, 3, 4. In this case, it's a 4-point next to the Likert scales. Lastly, number your questionnaires. Then I've showed you already the data capturing, how to capture it. There shouldn't be gaps, data sort, number. Right. Now that you've done this, we're ready to go to SPSS. And just to show you that if you want to get SPSS at CPT, you can do it via your supervisor. This is where you get the license. I'm not sure if you can see this page. It says SPS license, Salema Molopo, and here's his email. Can you see that screen?
Yes, we can see it.
So this is where you get the SPSS license from. So as a postgraduate student, you'll be able to get it if you want to do your stats, and you just work through your supervisor. But this is the contact person. So take a screenshot or write his name down quickly, because I haven't, the person changes from time to time, so I haven't included it in my presentation.
Prof, can I just ask a question?
Yeah, go ahead.
I know you've mentioned the sample size. Are you still going to go deeper into the sample size?
I'm not going to not covering sampling at all in this. It's not there's separate presentations. But what is your question?
Okay. No, because you mentioned something about
384.
Only about 300.
Yep.
384 years. What? Yeah.
There's a lot of.
Is that the maximum? Yeah.
There's statistical calculators. Let me show you something
Yeah.
quickly. Let me show you something. Let's just say Railsoft is the one I want. Railsoft sample calculator. Quickly, I don't want to get too sidetracked with this because it's not the point of the presentation, but I use Railsoft's statistical. Oh, can't be reached. Come on, be reached. Okay, it doesn't want to go. Let's try this sample. Okay, so here's a sample calculator. Can you see the screen?
Yes, we can see it.
Okay, so say your confidence interval is 95%, your marginal n proportion, okay, 50, you can leave all that, and your population size is, say you're doing CPUT and it's 35,000 people. And we go calculate. It gives you a sample size of 380, right? Say you're doing the whole of South Africa and we are, I don't know, 70 million, 80 million, I don't know, let's say 70 million, calculate 385. Yeah, that's as big as it's ever going to get, 385. If we try and put another naught here and say 700 million, it doesn't increase. It stays at 385.
Okay, because the reason I'm asking, because I was looking at this in my population size was about plus minus 700K,
Yeah.
and I got to a sample size of 1,200, but maybe I must use
No,
that
no, no,
calculator.
no. But you're probably going to use a non-probability sampling technique, right? So you use convenience sampling or snowballing, right? What sampling technique are you
Yes,
going to use?
the snowballing.
Yeah, so you see, those numbers are for random sampling. So in other words, this assumes that you've got a list of every single person that's on those 700,000 people, and you can randomly then select 384. But when you're doing convenience sampling, you can do bigger. I do talk a bit about sampling size. You can definitely go bigger. Somewhere between 500 and 1,000 is suitable. The one journal article I got says 500 is fine for non probability sampling, but others say, I make my students do more, because if you're doing a lot of cross tabulation, and now your sample size is too small, and you've got 10 groups, and in some of the groups there's 5 respondents, it means that when you do cross tabulation, it means nothing. So therefore you need to do bigger sample sizes so that in that group there's at least 30 people, because otherwise the data is going to be meaningless. So there's nothing wrong. I've had students who've had thousands in their sample as well. So you can, obviously, the bigger the sample, the better. But in non-probability, because it's non-probability sampling, I wouldn't go too much bigger than 1,000. Yeah, 1,200 is fine. I've got a student now that has 1,280. But yeah, a non-probability sampling, you can go bigger, but probability sampling, you can go smaller. Okay. Okay. So where was I? Okay, so that's Selema. I'm going to close that now. Okay. So now we need to set up, based on this questionnaire, or based on this, we need to set up this in SPSS. But I think I must just open this questionnaire again. Questionnaire data coding. So let's just open this. All right. So you're going to open SPSS, and now you need to code all of these different elements into SPSS. And I will just go back to the Word document. So I've opened SPSS. I can't make this, or maybe I can. No, that won't. I can't make this bigger, unfortunately. It doesn't want to go bigger, but just to see that you can see SPSS open, and you have to click Control scroll your mouse up on your screen to make it bigger. I won't be able to mine. Can you see this? SPSS is open. It starts on top with QuestNum, and then there's all these types numeric. Can you see this?
Yes, I can.
Okay.
Yes.
So now you need, great. Now you need to program this in. So question 1 is the region. So you give this a name. So there's 2 views. This is the data view. This is where your data is going to go, but you can't put it in here. And then there's variable view. This is where you go. So data view is where you'll put those numbers from your Excel sheet, but variable view is where you program it. So your first question was which region? So under the name, you give an abbreviated name with no gaps. So question 1, you put region. All of our questions are numeric, but firstly, you always start with QuestNum because this will allow you to sort. So QuestNum, you just say QuestNum, numeric, width is standard, no decimal places, no labels, no values, 8 columns, right, nominal inputs. Because that, if we go to your data view, is going to give this, so then you can, it allows you to input the questionnaires so that if you want to sort data in here, you can sort data in SPSS. There is a function, not that I show you, but if you go data and you go sort cases, this allows you to sort, but you can sort by questionnaire number as well to get it back into the original. So sometimes you want to do that. So your first step is to type in QuestNum, put this column nominal, you just select it. Your first question is regional. So you type in region, you would type in numeric. You're not doing any of these other things. A string is if you got quantitative, you'd always go numeric. So for all your questions in this questionnaire is numeric. Okay, so that's pretty standard. The column is standard, decimal, you always just leave at 0. Okay. Then you can type in the actual question, and let's just make it here. So you type in the question, which region do you reside in, is the label, and you can type question 1. Now you need to code the different values. So how do you code? Let me just delete all of these, just to delete. So now you want to code, so you just go plus, and then if in your questionnaire you see, oh, the first one is South Africa, and what number are we going to give it? We're going to give it a 1. So we go to SPSS, we type in 1, the value, and the label is, paste, South Africa. Then we click plus. The next value is 2. What is 2? 2 is Africa. So we go back to SPSS and we type in Africa, paste Africa, and we go plus, and then we type in the next value is international. So you've got to set up this SPSS. You've got to capture each question in your questionnaire, and you type in international, and you don't push plus, you just say okay. Oh, okay, we do have to, it does want to go plus. It didn't like that. We go plus 3. This is in version 30 there, and we go plus. Okay, there we've got the 3 labels. We go okay, and now you can see it's got the 3 labels here. Value Africa is carried by 2, international by 3. So if you code, and if you accidentally in your value type 33 in your data, you see there's no value. You haven't coded for 33. So obviously you don't do that. Then you've coded that. Missing data, you say none. You don't want missing data. You can say discrete or range plus 1. You can do things, but generally you want to collect so there's no missing data. I don't allow my students with missing data. We just chuck those questionnaires. Column 8, right align. This is a nominal question. In other words, it doesn't have a rank. Whether you're from South Africa doesn't mean you're more or less than someone else. So it's nominal. It's just, yeah, I think I described that there. So set tariff view, refer to the Cape Town. So choose a descriptive name. NB, there must be no spaces. Generally numeric for the type. The width is 11. The decimal is 0. I've showed you this label. Copy and paste your questionnaire in the ... Then I showed you how to input 1, 2, 3, 4. NB, note that for questions where the response permitted more than one response, each option is captured by a yes and a no. Missing, click none. Columns 8, right. So nominal is I'm not really going to look at the notes, I'm more just going to show you, and you'll get the notes afterwards. So the general questions do not have a meaningful rank, right? So there's no measured. Ordinal, they do have a rank, like strongly disagree and disagree. And scale, you select if it's left open-ended and you need to put a numeric value, like a mark or the actual age. Okay. And I generally use the role, I use input. The first question can be captured, question number ID, as I showed you. So, right. So you've captured that. Now you need to capture your next question, and you copy and paste this in, and I'm not going to do this for each question because we don't have the time to. So now the next question is questionnaire 2. You say CT attraction, you copy and paste your questionnaire in, you code it. 1 is Table Mountain, 2 is Victoria, 3 is Cruz Sanchez, 4 is Cape Town, 5 is Kirstenbosch, 6 is other, this none, 8 is also nominal. You do your next one, social media site. It's all the same. You cut and paste your question in there. Which do you access most? You code your data as well. 1 Facebook, 2 Twitter, 3 YouTube, 4 other, and it's also nominal. When you get to your cognitive questions, you just give them code. Cog 1 to 6, affect 1 to 7, behave 1 to 3, and this you can copy and paste all of these at the same time in the questionnaire. So if I go here, you can just block all of this, but okay, in PDF, it's not going to let me just block this, but you just block this column in your Word document, and then you can come to SPSS and you can literally just, you can do that and click paste from your Word document, and I'll put all of that in at the same time. And then you just code this. Oh, somehow I've made that 1 decimal. We don't want decimals. You can see, I can see there. And then here you just go 1 strongly agree, 2 disagree. Most of you have 3 neutral, 4 agree, 5 strongly disagree, but we don't have neutral in this. It's 1, 2, 3, 4. And once you've done this, you can actually literally go, you can actually, if it's the same, you can just go copy, and you can copy it in here, so it's much quicker. And then you code your last few access, login, age. You code all the different variables, PC, give them their codes. And once you've done this, you will get to this. And then this would look, once you've coded it, this would all be blank. It would be like this. It would look like this. And this is the data view. Let's go back here. So it would look blank like this. And then once you've done this, you can actually take your data, you can copy it, and you can just copy it all the way down with your question 384, and you go copy. So that's why you do it in Excel. Each column, you can see it's created a column for each question, like you had in your SPSS. You see, it's set up the same way. Each question is a column and denoted by 1 number, except for questions where you can say tick more than 1 response. Then you need a column for each response if you that. But if it's tick 1 response, you have 1 column. If you can say tick more than 1 response, you're going to have a column for each response. So just very important. If you said you can tick all of them and they could tick Facebook, Twitter, and YouTube and other, then for question 3, you would have question 3 Facebook, question 3 Twitter, question 3 YouTube, question 4 other. If they tick it, it would be captured by 1 yes. If they don't tick it, it would be captured by 2 no. So just remember that. I just wanted to tell you that it is in the notes as well. Then in this Excel sheet, question 3 would be, you would have question 3 1, question 3 Facebook, question 3 Twitter, question 3 YouTube, question 3 other, and it would captured by 1 or 2. It's not very good to use those questions where they can tick more than 1 response because it limits the statistical tests that you can do on it. But anyway, you've got all of them, and once you've got that, you can just go here and you can right click and you can click paste. And then it inputs all the data for you that would have been blank. These other columns here is other stuff we're going to do later. Okay, and there you go. and then you can save it. Okay, but I just want to undo everything I've done here. Let's just check that I haven't messed too much with this. Yes, okay, that's fine. Okay. And then, so you've got so once you've coded this, you're able to then go to the data view and copy and paste your data. And now we're ready for the statistical analysis. And now we actually start with the fun stuff, but this has to be done. You have to set up your Excel sheet first, based on your questionnaire. And then from there, you can set up your SPSS, copy and paste your data in, and then you're ready for statistical analysis. And now we're going to go through the different tests. Any questions up until this point before we start with the fun stuff? All good? Okay. Now we need to do the different stats that you need for your, we need to do different statistical measures. Okay. Yeah, before you start, just show that you click Edit, Options, Output, Labeling, Variable Labels. I select Names and Labels under the under the variable labels in the pivot table. So all I'm saying is just go here, Edit, Options, Output, and here under the pivot table, we generally want names and labels. Okay, that's what we're saying. And here on online, we want names and labels, and here we want labels, and here we want labels. But when you do regression analysis, you may just want to change this to labels, but we won't worry about that for now. So that's just something I wanted to show you. So you've got that in the notes, and it's quite easy, as I say. You just edit, output. You just follow exactly what I've said here. Then under pivot table, I've showed you that, and ever you need to change, as I say, jumped. I don't know why it jumped. However, you need to change the names and labels to names for factor analysis to do the pattern matrix, but we're not doing, we're not doing, you're not going to do structural equation modeling, but that's what I'll say. Right, so now there's different things that you can do. I always start off by doing some descriptive analysis and frequencies to ensure that there's no missing data. So how do you do your frequencies? Well, let me just, I'll give you all the notes here, but it's easier just to show you. So we want to check that there's no missing data and everything's right, and this is what you can use to create your graphs from. You just go analyze, so this is the most important button. You go descriptives, you go frequency. Now you put your finger on region, the first question, and you put your finger on shift and the down button, and we're going to create these things later. So all your question numbers, region to age, you shift across and you just click OK. And now it tells you, is there missing data? And you can see in this instance there's nothing, but if there's missing, it would show you one. And if you scroll down, now it shows you which region you reside in, and because you've coded it correctly, 272 from Africa, from South Africa, 55 and 57. That's why you want bigger sampling, because if we sampled this too small and there were 5 people from Africa and 7 people from international, you can't do any cross tabulation. So if you have a question with 10 responses, you may have to do a big sample to ensure that you've got people ticking at least 30 people in each response, because otherwise it's meaningless. Here, this cross tabulation is meaningless because 273 and 70, but look here, Groot Constantia 5, 15, 7, 14. This can't produce significant cross tabulation results. We needed to interview more people. Okay, but she did actually. I just took 384 from her survey. She actually did more. And here as well, Facebook, okay, they're all basically 30. So it gives you all the results, and then you'll strongly agree and disagree. It doesn't matter here if there's smaller number of people, because that's their attitudes. And then it gives you then the frequencies, that they use it, they log on, how many, male, female. and different age. And if you didn't, let's just show you if you made a few mistakes. Let's just say, I just want to show you this quickly. Say you had this as 11, and you had this as 44, and you had this as 11, and you had this as 33. Okay, and now I do the analysis. We just go to descriptives, frequency, and we go okay. See, South Africa, Africa International, what does it show? It shows 11, 111. There's no, you didn't code 11, you see. Here it shows the 44 as 44. Here it shows the 11 as 11. Here it shows the 33 as 33, not the correct. So you see, if you make mistakes, this is what happens. So right, let's just go undo, 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 undo. And let's just do the analysis again to show you how to export it. There we go, frequencies, and we export, and we go, okay. And now you want to export it, so you can just go File, Export. Usually by default, it selects Excel, but always export it as Excel. You see here, Excel. And then you select where you want to put it. So we go browse, and let's just say we want to go to, just go to C, and we go to 2025, and we go to postgraduate, and we go to research workshops, and we go to SPSS, and we put it in here, and we just say frequencies, right? And we click, and we just click save, and then you click OK. Now it's going to export this to that folder that you've asked as an Excel file. So if we go into this file and we go into SPSS, there it is, frequencies. We open frequencies, and here it is. It gives you all this gobbledygook. So this gobbledygook I just delete. We don't missing data we've checked, so I just delete all of this. And then usually, and you see it gives each one labeled, gives frequency, percentage, valid, cumulative. Usually we're not worried about the frequency, we're not worried about the percent, we're only worried about the valid percent, we're not worried about that. So I just leave valid percent and make it big. And here you go, here's all your frequencies for all the questions. Now it's quite easy for you to create the graphs, which is always the first part. You would just go block this, the different variables. You go insert, you select your chart, bar chart, delete the chart title because you would label it, right click, add data, and there's your graph for the first one. And you can play around with it. There's different styles, you can play around with the colors if you wanted the colors differently, you can do that, and there's your first graph. Just move that away, and then you want to do the next graph, then you can just do, insert, chart, whatever, there, right click, there's your next one. That's how quick it is to do the graphs you need, and you've got everything. These constructs though are different. You're not going to show a graph for each variable. What you generally need to do is, I usually write a formula for it, but to do your graphs for your Likert scales, you've got 6 for this Likert scale, so then I usually just write code. So this is C38, so I'd go equals C38, and then it's going to take that value up, and I just drag it down. This is C46, so it's every 8. C46, and this would be, I needed to go equals every 8, and this will equal C54 equals C62. What was that? I've lost count. This was 54, so this is equals C62. And there's 6 in this contract, so this will be equals C70. So what I've done is I've just taken the first one of each of these for the 6. Yeah, that's C46, 54, 62, 72. So these are the first 6 cognitive. I've taken the values there. Then you can drag it across and it's taken all. So this is all just taken the code. So I've taken all of these values and it's taken these 6 values, and I go equals sum, take that, the 6 items divided by 6, get the average for each of these, and we'll just go format. We want 1 decimal place, number 1 decimal place, okay, put it in bold. Then I take the strongly disagree and I cut and paste it here, and I take then these and I cut and paste them as values, and then we can block this and go insert chart or recommended chart. We want that one, okay, delete the data label, right click, add data label, and there is then the weighted average for your 6 cognitive. You wouldn't have a graph for each, you'd have one graph, and here you can see strongly disagree, disagree, agree, and agree. So this is the weighted average for the 6 items measuring the cognitive attitude. And so we would have 3 graphs in this, and then you could, and then you would do the same for affective and the same for behavioral, and then you can do your demographics. And demographics, I always use pie charts, and delete that and right click, add data label, and there it is. You can also play around with this as well. If you want to move this to the side, you can do that as well. You see, so you can play with different things, and there it is, and so you can do the rest. So that's what all my students' theses start off with this, like the graphs. So don't say, and it's very quick to do that. Any questions regarding the graphs or frequencies? Are all good? But you see how quick it is. Within an hour, I could have all my graphs that I need for just as descriptive stats, which you give before we get to the nitty-gritty. Okay, so you export your frequencies, you have your file, you can do your graphs. Then you do descriptive stats as well. So for the means and standard deviations for the individual values. And you can also do it for the collective values. I just want to see how far, to create a group. I'm going to do that now as well before I do reliability. Or I can show you how to create a group. So before we do the descriptives, I'm going to kind of jump to this creating an average. So like we did that graph where we added those 6 constructs together. So now you want to do that. You want to do that in SPSS to add the 6 together so that you can then use them for cross tabulation purposes. So we don't want to save this output. So we go back to SPSS. Now we want to say these 6 constructs, we don't want to have 6 values. We want 1 value for cognitive. We don't want 6 values for affective. We want 1 value, and we want 1 value for the behavioral. So you'd go to transform, compute variable. You'd give it abbreviated heading. So we call this cog, maybe. Right? And then we go down here, we double click statistical, and then we click mean, and then it does this. It gives you question marks. You can just delete those question marks, and then we go to the actual cog1 here, and we double click on it, and then we click a comma, and we double click. We do a comma, double click, we do a comma, double click. So we take in the mean of these 6 values, and you click OK. Then it's done. We do the next one. Transform, compute value. You want to do the 6 effective values. You want 1 value. So you say effective. You can now just delete these cognitive, leave the brackets, and we go effective 7, effective, double click. Next one, double click 1, double click 1, double click 1, double click 1, and there it's going to create. You click OK, and then we do the last one. Transform, compute variable. We want to combine the 6 individual Likert scale items for behavioral. Double click, comma, double click, comma, double click, comma, 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 and you click OK. Oh, but cancel. We need to change this to behavioral, BHF. BEH. There we go. And we click OK. Right. Now in the variable view, you'll see it's created cognitive, affective, and behavioral. There I'd already done it. You can see cognitive, affective, behavioral. And then I just change these decimal places to naught as well, because otherwise it creates chaos when you do that. So change it to naught. So there it's created it. So I'm just going to actually delete these three variables. Clear, because I've done it there. They have created cognitive, affective, and behavioral. And if you go to your variable view now, the actual data view, and we scroll across, you'll see that it's created cognitive, affective, and behavioral, and it's given it a value. So this is the average value for the 6 statements for questionnaire 1. For cognitive, affective, and behavioral, questionnaire 2, these are the average values. And these are useful for later on. Okay, so like we did with these graphs, we've converted these into one values. This factor analysis we'll get to later. So let's go back to the notes. So now you've created a group for the 3 variables, and that becomes important later. Before you create the groups, usually, it's important just to do your reliability measures and even your factor analysis to check that those variables are right. But for the purposes of this example, we're just assuming that those 6 variables are correlated to each other. But you also want to do your Kronberg alpha as well to check the construct. So we have 6 items for cognitive, 6 items for affective, 6 for behavioral. We want to check that they're okay, and those values should ideally be above 7, which measures the reliability. What is reliability? It means that if you were to test and retest reliability, it measures the internal consistency. So a scale that's administered twice to the same respondents on different occasions should produce the same results. So internal consistency is the degree which the scale items measure the same attribute. In other words, produce similar values. So that's why it's important to take items that were pre-created and already tested for reliability and validity. So we need to, though, now that we've changed the context, we need to measure the reliability and validity. And how you do that is quite simple. You just go analyze, we go scale, we go reliability analysis, we check the 6 variables that we want to check, we put them across under items, we type in here cog or cognitive, and we click OK. And here it said it's 0.862, which is excellent. It's above 7. So now you want to do the next one, analyze, scale, reliability analysis, and then we just put the cursor here, click shift, up arrow, move it back across, take effective, shift, take these 6, take them across, remember to label it effective, but effective. And what you can do though is if you want to just check, you can go statistics and you can click scale if items deleted. You want to check that these are the strongest 6. So let's just show you that function. Scale, and you click continue and you go OK. So here it gives you the value of 813, and then it says if you deleted item 4.7, it would be 7.83. If you deleted item 4.8, it would be 793. So you can see if you deleted any one of these items, that 8.13 would have actually gone down, which is no good, which means that these 6 items together give you the strongest reliability. And we could do the same lastly for behavioral. We just block this, up arrow, move it across, shift, down arrow, oops, we don't want that, go in, we want to change this to behavioral, and we go OK, and it gives us 871, and if we delete item 13, 865, 855, so none of these values are above 871. By deleting one of your constructs, it's not going to increase reliability. But even if it was going to increase reliability, I wouldn't delete it. As long as your value is over 7, that's fine. You would first want to test the validity as well, because in deleting one item, maybe decreasing your validity. It's better that your constructs have between 3 or 4 or 5 items. It's not good to have a construct with 2 items because that will definitely affect your validity, which we'll get to later. So as long as they're above 0.7, that's good. You can test your validity. Sometimes deleting an item would also increase the validity, but we'll get to that later. And then you would just, to get these 3 items, really you only need this number, which you'd put in a table. You just go File, Export, and then you could just type here Cronbach's Alpha, Cronbach's Alpha, and it will already take it to the correct screen. Leave that and you click OK, and it would export that. And then if we went back here, you'd see here's Cronbach's Alpha, and it, it provides you there. It says cognitive, and there it gives you your effective, and this you wouldn't report on this, and then it gives you your, you just after that one value which usually goes in the table. Okay, we can close this. Don't save. Okay, and we can close that. We don't need that anymore. This we still do need, and we'll go back here. So that's the reliability done. I've showed you how to create a group. So now we can start testing. Did I even show you? Do I show you validity later on? I probably do. Now we can start testing some of our research questions. We could use a t-test to test where there are 2 options. So the only option we could use a t-test for is if we go to our questionnaire. So t-test can only test where there's 2 response options. So there's 3 options here. You can't use a t-test. There's 5 or 6 options, 4 options. This you don't use. But if we go down for male and female, there's 2 options in this questionnaire, male or female. These days you have non-binary and other options. But in this instance, she had 2 options, male and female. So then you could use a t-test to see if there's a difference between male and female in terms of the 3 attitudes, which was one of our research questions, or part of our research questions. So let's see how we do this to do cross tabulation. So let's just first go close this. I don't use t-tests very often, I must say, but some of you, because they only do 2, I usually rather use a generalized linear model, which I will show you later. So an independent t-test is used to compare the means between 2 scores. I'm just going to open it on my other screen as well. Frequencies, descriptive, reliability, create t-test. So it's used to test 2 mean scores for a certain condition. A t-test is limited to 2 groups, either male and female, or yes and no. So if you had yes/no questions and you want to see if there's a difference versus one of your constructs, you can. So here we had the research question establish if gender, in other words, a demic variable, had an influence on CAB attitude. So how do you do this? So let's analyze, compare. So I'm going to take you through the different steps and show you how it works. Right. Let's go into Excel. So to do a t-test, you go analyze, you search for compare means, and you want to click on independent t-test. So compare means independent t-test, right? Then you want to select the variable. So you see you can't move 6 individual variables. That's why we've computed cognitive as one variable. So we move it across into test variables, and then you want to select gender is what we do in the cross tabulation to the grouping variable, and then you want to define groups. The values are 1 and 2. That's fine. Click continue, and then you click OK. And now it gives you your results. Here's male, standard deviation, F, significance. 0.995. So is there a significant difference? You're looking for the sig, which I'll show you what that is. 0.995, there's no significant difference. So you could repeat the test now. You could go analyze, compare means, independent sample t-test. We move out. Cognitive, we move in. Behavioral, we put it in, we click OK. Is there a significant difference? 0.921, there's no significant difference there. And then we can do analyze, compare means, independent t-test, we move effective out, and we move in behavioral, and we click OK. And 0.107, close but no cigar. And you could export this data afterwards because you'd still, report on this. How do you report this data? Let's just show you. So this is how you report the independent t-test. Show there's no significant difference, and you say p equals 0.995. You'd give the t value. So if we go back here, the t value is there, 0.095. So you would report on that. Is 0.95. Between males, you'd give the standard deviation and mean for males and the standard deviation and mean value for females. You can see 3.16 to 3.12. They're very close together, so there's no chance there's a significant difference. Where do you get the mean values? Let's just quickly go here. Here it gives you the mean and standard deviation for male. And you can see immediately there was not going to be a difference because the mean values for cognitive, attitudes towards tourist attractions, social media marketing, communications is very, very similar. And you can see for effective even closer, and you can see for behavioral very close to the mean values. So there was no chance of a significant difference. And then you just report each one like this with the p-value, the t-value, males, means, and standard female teams in terms of cognitive attitudes. There was no difference, and that's how you'd report those three. Okay. Please note that values are significant difference if they're between 0.00 and 0.1. That would be significant difference at p equals less than 0.1. If the value, the sig value or p value is between 0.02 and 0.10, it's significant at p equals less than 0.1. And if the value is significant and if it's 0.011 to 0.50, it's significant at p equals less than 0.5. Values that are over 0.051 to 999, there's no significant difference. And you can see that from these values, all these p values, 995, 992, and 107, absolutely no significance. Okay. Just to go back here, I'm not sure if you've followed me at all. But this is just very, very, very basic stats, which, hopefully you've all dealt with significant differences somewhere in your undergraduate study. But basically, that's what you're looking for in your postgraduate studies when you do cross-tabulation. It may not be meaningful to you now, but it certainly will when you do statistical analysis. So then how do you test when there's more than... So now we want to check the first research question, is there a significant difference between these three variables and cognitive effective? Is there a significant difference for these 6 variables and cognitive effective behavioral? So a t-test can't do this, so we can use a ANOVA test to check if there's a significant difference. So let's go back to the notes. So ANOVA is used to compare the mean scores for more than 2 different groups. ANOVA compares the variance. A large F value indicates there's greater variance between the groups. A commonly post hoc test. So ANOVA will just show you that there is a significant difference. The post hoc test will show you where the significant difference is. So we mostly use Bonferroni. Okay. If you use ANOVA to compare means between only 2 groups, then the post hoc test will not be performed because there's fewer than 3 groups. Because if there's only 2 groups, you can see where the significant difference is between male and female. So if you use ANOVA to compare male and female, it would not do the post hoc test. It would just show you whether there's a significant difference or not and give you the means and standard deviations. Hence, ANOVA is generally test. So let's have a look at how to test for the first one, is there significant difference for the actual Cape Town tourist attraction compared to cognitive, cognitive, affective, and behavioral? So let's just run those tests and close this. You can export this data, but I'm not now, no. And let's just close that. We don't need that. So to do this, we go to Analyze, Compare Means. We click one way and over. Okay. Now the dependent variable would be cognitive. So we move that across. And the factor would be whatever we want to test. In this instance, we want to test the region. So we move the independent region across. We select post hoc. The post hoc test we want to do to show us where there is Bonferroni. So you put that, right? Then you click continue. Then you click options and you select descriptive is what you want. That will show you the means and deviations. You click continue. You click OK. Okay. So here it's giving the mean values. You can see 3.18, 305, 311, and it's giving you the standard deviations here. Okay, the significant value is 0.031, and then it gives you the the post hoc test. It compares. South Africa is a difference from Africa to international, Africa to South Africa, and international South Africa and Africa. If there's a significant difference, it would show an A here. It would have a little A next to it. But this SIG shows no significance at all. So then you would repeat it for all of the different questionnaires. But unfortunately, none of these are significant. So let's go to something where is significant is access. So let's close this. You need to now repeat this test for region affective, region behavioral. Then you need to do the test for tourist cognitive, tourist attraction affective, tourist attraction behavioral. Then you need to do it for social. So you need to do it for each attitude and each independent variable, which is region, tourist attraction, social media platform, access, login frequency, gender, and age. And that would answer all of your research questions, but not your hypothesis, which we'll go to later. So let's just do this. So you literally have to perform 21 tests here. I will show you how to do the generalized linear model where you can perform those 21 tests in 3 tests to see if there's a significant difference in terms of those 3 attitudes. But let me just show you now. Analyze, we go to compare data, we go to compare means, we go to one way and over, we leave cognitive in, we take out the region, and now we go to where I know there's a significant difference. We're going to move this. You don't need to now change each time the post hocs. It will remember that Bonferroni is there. It will remember that you click descriptive. So it's quite quick to do the test if you know you go cognitive and you put in region, cognitive, social, the ST attraction, Cape Town attraction, then the site, then you could put in log-on frequency, gender, age, etc. You know, you could just move them in one at a time for cognitive and then do it for affective and then do it for behavioral. And then, you know, you would just move that in and out. But let's go, okay, we've done for access. And here you can see there is a significant SIG at P equals less than 0.001. You see now the ANOVA shows you that there is a significant difference, but it does not show you where the significant difference is. And if you scroll down here, it's very small. You can see there's a little asterisk next to PC is different from tablet and from mobile phone. There's a little asterisk there. Laptop is different from PC and mobile phone. And then the reverse, the converse is true. So, you know, if it's showing PC and laptop, then tablet would show PC. So you look where the most A's are, and you can see PC and laptop are both different from tablet and mobile phone. So now you look at the mean values, you have to go up to the mean values, and you can see PC and laptop are significantly different from tablet and mobile phone. And can you see the mean scores? These are 294, 294, but tablets 3.24 and 3.16 the mean. So you can see the means are significantly higher for tablets and mobile device compared to laptop and PC. So that is a significant finding, and you can see it by the mean values. And then, So you would keep that, export it. I'll show how to report on it in a moment. And then, you could repeat the test. You could go analyze, you go compare means, you go one way and over, you go back there, and you move out. Let's just say we want to check access for effective. Move a dependent variable, we leave the access in, and we go okay. And then you can see that again, PC is different from tablet, tablet's different from laptop, and those are just the reverse. So tablet 335, you can see the mean is significantly different from laptop and PC. So tablet is the more positive attitudes because it's got a higher mean, whereas laptop and PC have the lower means. And then you could repeat the test, obviously, for the next one. We'll just not get carried away and do too many. And we move effective out, and we move behavioral in, and we go, okay, we leave access in. We do the third test, and here you can see a significant difference, P equals less than 0.001. Where's the differences? Here you can see PC is different from laptop, tablet, and so it's PC that's different. So PC it's got a much lower mean than these three, 3.18, 329. So these three are more positive than PC in terms of the behavior attitude. So it seems like the mobile devices, because the laptop's also mobile, results in more positive attitudes towards behavioral intentions of tourists in terms of, the behavioral attitudes. And PC is the least positive, and these are more positive. How would you write this up? So if we go to the notes, you repeat the tests for effective and behavioral, and then, the independent variable, by the way, is a predictive variable. It's the cause. The dependent variable is the outcome variable, the effect. The value depends on the variables of other variables being tested. So I just showed you how to do it, and then how you would do this is you would record the significant values in a table like this, and then you would see what's significant. So you would put 3 asterisks next to it where it's significant at p equals less than 0.001. So all of these gave you 0 values, as we've just shown. If you do log on frequency, it gave you a value of 0.37 an asterisk. This was 0.00 and this was 0.0. So this is 3.7, so it's 0.350 actually, and that's 0.310. So you can see it's just significant. How you would write this up? So we did this example respondents. You used a tablet, you'd give the mean and standard deviation number, and mobile phones to access social media. Showed more favorable significant cognitive attitudes. You'd give the F value and the P value towards Cape Town tourist actions in comparison to laptops and PCs. You see. And then it's the same for the effective respondents. You used laptop, tablets displayed more favorable attitudes towards personal computers, laptops, and mobile phones. And you give the mean values and the F and the P values. And in the same way, log on frequency. Tourists who logged on multiple times a day, you give the mean standard deviation, found more positive attitudes than those who logged on less often, 2 to 4 times a week. You give the mean and standard deviation. And that's how you'd write it up, each one. Okay, based on the output. Then there's a much quicker way to do it. So ANOVA looks at one variable at a time, whereas you can do MANOVA or a generalized linear model, which is based on wild chi-squared, where you could do all of the statistical results at the same time. It may not deliver exactly the same results because ANOVA is based on ANOVA, and GLM uses a wild chi test, so it's slightly different, but it also looks for a significant difference. But just to show you how to do that, instead of running 21 tests, you can run 3 tests. And let's have a look. So you'd go analyze, you would go generalized linear model, you would click nothing there, you'd click response, you would move the cognitive variable here, dependent variable, you'd move all the predictors we want to test. So we want to test region, click control, region, control, block it. Want to check access, that, gender, and age. Those are the 7 variables. We move them under 2 factors. We go to model, there's nothing. We just need to block these 7 variables then, go down. We just say test main effects, we move them across here. we go to estimation, no, statistical, no, EMNE, and then we block all of these 7 variables again. We take them across. We change this to pairwise. We wanted a pairwise Bonferroni. Nothing really to understand here. It's just a matter of being able to do it and then interpreting your findings afterwards. Bonferroni, and we click OK. And let's just do the other two quickly now. So that's going to do your cognitive, but just how quick it is now. You go analyze, generalized linear model, you go back to response, you change cognitive, you change nothing else, you move effective in and you click OK, and it will do all of it. And you go analyze, generalized linear model, move effective out, move behavioral in, and we go OK. And there you go, it's done all of your tests, those 21 tests you would have to do in ANOVA. It's done it all for you. And then you can export this data file, export to wherever. But it then gives you your overall mean and standard deviation. We actually didn't even do the descriptive stats. I'll show you how to do that afterwards. So there it gives you the overall mean for cognitive is 3.12 and the standard deviation. And then the omnibus test, it shows you out of those 7 variables, there was something significant. So it's given you a p-value of 0.07. And then it shows you what's significant. And if you look down, it's how do you access was also significant at p equals less than 0.001. But the significance, in other words, how often you access was not significant. So then you've got to scroll down for the pairwise to see where the differences were. So how often do you mostly access? You ignore all of this until you get to how often do you access. How do you access? It shows you that tablets and PC were different. Tablets and mobile was different. So you can see that again, 291, 292. So it produced pretty much the same results here. And you report it in a similar way to ANOVA. And there was nothing else significant here. So we scroll down to the next Bonferroni test, which we did for, let's go up. So this is the next one for effective. It shows the mean and standard deviation, 3.23 for all 6. It gives you that there was a significant difference amongst those 7. And then it shows you that, yeah, how often do you access? 0.001. And that is significant at p equals less than 0.01. How often do you log? So it produced the same result as ANOVA. We scroll down now to the Bonferroni pairwise test to see where the difference is. And access, you can see tablet was different to PC, tablet was different to laptop, and you can see here's the tablet was different to the 3 of these. So it's showing you the tablet in this instance was more positive, 3.23, than laptop, PC, and mobile phone. And then if you go to how often do you access, so you see it was significant at p equals less than 0.9, but it's not showing you with that little asterisk where the significant difference is. So you need to look at the means, and the one that has the highest mean is mobile. So that one's definitely going to be the positive, and the lowest one, you generally look at the lowest one, but you also look at the p-value because of the standard error. If it's too high, it means there's few respondents. But here you can safely say that those who accessed multiple times a day was more positive than those who accessed 2 to 4 times a month. You would have to make that call because it didn't show you where it was, but the highest, and not necessarily the lowest, but the p-value with the standard error was okay here, so you would compare it to that. And then if we looked at the last one, here it's shown a difference again for access and again how often do you. So you see it produced 5 of the same results to ANOVA. So you need to decide whether you're going to do 21 ANOVA tests or 3 generalized linear models. Right, we won't export that. And how do you report on that finding? You would create a table. Where am I? Generalized linear model, yeah, perfect. This is just a table where you could report in the means and standard deviations and significant values for each one, where it showed you the significance. And then you can have the cross tabulations where you record the significant values. for the 7 variables which you took from the table, and you use the asterisks to show where the significance were, and then you can write it up. The same respondents used tablets, showed more favorable attitudes the same way as ANOVA. Yeah, basically shows you the significant differences. Log on. Oh, and there was another one, region, which wasn't significant in ANOVA, but it was significant when we did the worldwide test. So you could decide which test you wanted to do. You could run all the ANOVAs, you could run all the GLMs, and use the statistical test that gave you the greatest significance. So you can choose different models to give you different findings, although they give very much similar findings, ANOVA and worldwide square test. Something I forgot to show you, which you could also report on, is your descriptive stats. You go analyze, descriptive, descriptives, and you want to do descriptives usually for your individual items. If you're going to have a table with the individual items where you report on various things, so you move that across, just your Likert scales, and you move your cognitive, control these 3 variables, control, and move them across, and then you go. It does that, gives you minimum, maximum. We don't actually want minimum, maximum, so don't save that. Let's just go to analyze, descriptives. This I should have done after the frequencies, but I first did the where I combined it. Then we want to move these across, that and that across. And then we want to go to options, and we want to take away this minimum and maximum. We just want the mean and standard deviation. Click continue, click OK. And then it gives you each one, the mean value for each item. Sometimes when you're reporting your validity, you do this. And then it gives you the overall, which would be the same as the GLM for each. Cognitive, the mean was 3.14, so slightly positive. They were all slightly positive, 323 and 320. And it gives you the standard deviation for that. And you can see those results were the same as the results that when we did the GLMs, it produced the same results over here. Except you're getting p-values because you use the GLM to compare difference. And these p-values are significantly different because it meant there was at least one difference in each of these. That's why they had significance. And we're getting towards the end. Just to show you now, so we've answered all of our research questions because we've done cross-tabulation for all the different variables. And if we go back to these research questions, just to show you what influence do they have? There's no influence. How do tourist attitudes differ across the different due to? Okay, so this question, there was no significant difference. How did tourist cabbage differ across different social media? There was no significant difference. What influence do usage variables, access and login frequency? We found that both access for ANOVA, all of them, and login all found significant differences in that people that used mobile devices and tablets were more positive than those who used PC and laptops. So that would be your conclusion. People who logged on more frequency were more positive than those who didn't. So this question was definitely you would write up on. What influence to demographic factors? There was no influence on. So you've answered all your research questions statistically. Then now you need to answer your 3 hypotheses. Does cognitive have a positive on behavioral, cognitive and affective, affective to behavioral? So let's go to that part of the question. So now we need to do regression. Just get down to regression, GLM. I'm just catching up on the other screen quickly. Regression. So regression is the simple way to measure these relationships. You can use more advanced statistical processes. Regression. Okay. So linear regression determines the strength of relationships between independent and dependent variables in a straight line. So perfect regression would have a value of 1. Linear regression uses the estimated standardized beta coefficients, and it also uses R squared to show you the variance. So how would we determine these relationships in linear, and I'll show you to prove our hypothesis or disprove them. So we go in here, we go analyze, we go regression, we go linear regression. The dependent variable is the end variable that we want to go in. So firstly, we want to measure cognitive into affective. So we take this variable. Yeah, there's something else I wanted to show you, but let's do this first. So the variable that, we want to move affective. So this is a variable that's going to go into dependent, and the independent variable, which is going into affective, would be independent. We move it like that. And yeah, I think that's all we need to click. It's got estimates. I think it's, yeah, we don't need to really click anything more. We click OK, and it gives us the results. It says, is there significant difference? Yes, p equals less than 0.001. The standardized beta coefficient is 547, so that's a very strong relationship. It's over 0.5. It also shows you that as R, but it's standard betadized, and it's significant at p equals less than 0.001. And also another factor that you want to report on is the R squared value as well is 299, and you want to report this T value is quite high at 12. So how would you report on this? It is significant. Let's just quickly do that before we do the others. So you would say the standardized didn't showed that tourist attitudes exalted a positive on affective attitudes. Cognitive was positive on affective. T was 1277. The beta was 547, and the p-value was 0.001. Now you want to do the next test. The next test is, what is the next one? The next test is, we want to look at cognitive on behavioral. So we go analyze, we go to regression, we go to linear, we move out affective, we move in behavioral, and we put it in and we click OK. And here we can see again a value of 0.001. 0.001. It is, the beta value is 509. There it is again, 509. The T is 11.52, so it's high, and it's 0.001. So cognitive attitudes have a positive influence on behavioral attitudes due to social media marketing communications due to tourists who go to whatever tourist attractions. And then the last one was analyze, linear regression, linear. We want to look at whether we can move that out, or we want to move that out, we want to move that out, whether affective has a positive influence on behavioral was our third. Affective is the independent now, and that's affective, and you go okay. And if we look at it, it is 577 or 577. The T value is 13 at 0.001. 0.001, so there's strong significance. The R squared, the variance is 0.33, which is okay. So this is how it said. So it was positive there. Cognitive had a positive on general attitude. You give the T value, the beta value, the standard deviation, and affective had a positive influence on behavioral. You give the T value, the beta value, and that, and then you give the R squared value. So cognitive and affective explain 38.6% of the variance. How do we get that? Well, what we can do is we can just go in here, we go analyze to get that combined, because we've got two variables going into behavioral. So we go linear regression, linear, and we also put in cognitive at the same time. Here we put both in so we can get the p-value. We do them separately, but if you put them both in, we after this R squared value, which shows the variance at 38.4, because then it gives different t values. So we still need to do that, both that affective and cognitive in our model goes into behavioral, so we can get the combined R squared value for that. So let's go to the notes. So we say cognitive had a positive influence on behavioral, 509. Effective as a cognitive has a positive value on effective, 549. That R squared for both cognitive and effective going in here, we put here. The R squared for cognitive going into effective will give you an R squared of 299. This won't have a R squared because nothing's feeding into it. We put the beta values here, all were significant at p equals less than 0.001, so you put 3 asterisks. So therefore you proved your hypothesis, that your original hypothesis was this, and this is all a hypothesis is between two variables, was cognitive attitudes have a positive influence. You proved it, so you supported this hypothesis, you supported this hypothesis, you supported this hypothesis. And there's one more thing I can show you, I think, factor analysis. And this is how you get your validity. You should have done this long time ago. Before we did anything, you usually do the factor analysis before you do your reliability and validity test to see that that there's discriminant and convergent reliability. Right, and you need to assess if the data is suitable for factor analysis. Firstly, sample sizes need to be large enough, so at least 150 respondents. However, the rule of thumb is at least 10 respondents, or maybe 5 for each item. So we had 18 Likert scale items, so you should have at least 180 respondents, but of course there's other ways to test that. Yeah, there's other factors. KMO is used to test the sampling adequacy. So Bartlett's test is to test the factorability. You'll see all of this. And you can create a group. Yeah, the factor analysis would be generally computed before the reliability, as I said in 6.2, but it didn't make sense to do this now. I'll illustrate the principal components analysis, so all of these steps, and then how to report on the principal component analysis. So let's just do this quickly. We close this. Close this. So you would have done this before the reliability on your 18 variables. So let's go. You would go analyze, you would go dimension reduction, you would go factor analysis. You would move your 18 statements together like this. Move this across. Under descriptives, you would click KMO, Bartlett test, you'd click continue. Under extraction, you'd click scree plot. We're not going to fix the number of factors. You can, like we've only got 3 factors, so we're hoping the factor analysis will come up with the 3 factors. But if not, if they came up with less, then you could click fix number of items and you could force it to 3. Or if you had 10 factors, you could say 10 and see if it actually matches what you're doing. This is why it's so important that you have developed those Likert scales from reputable sources, because if you haven't, this is going to be chaotic. But we'll base it on agent values. You won't base it on fixed number of values. Agent values generally are 1, so you just click continue. You go to rotation. We click Promax is the common. You click continue. You go to score. You can save the variables. We're going to click this, save the variables. So in other words, whatever factors it identifies, it will save it as a different variable, which you could have, instead of combining the items together, this would do it for you, where you could do the regression then for them. Instead of transforming the variables into cognitive effective behavioral, this would do it automatically, but we're going to say save the variables in this instance just to show you, and then we're going to click options. We're going to suppress the size and we'll just say 0.4. Check, and then we're going to click continue, and then we're going to go OK. And that's going to take a while. Here we go. So now we look at certain, it's giving you a lot of value. The Kazem Bartlett's 0.950, which is excellent. That's a KMO is good. The sampling adequacy is excellent. I'll show you how to report on this in a moment. The SIG is 0.1 for the Bartlett test, which is good. We don't do anything on the communalities. It shows you there's 3 variables. And how many variables did we have? 3. and all of them are above 1, so it means it showed you 3. The scree plot shows you that there's 1, 2, 3. So after 3, I mean, it shows you that there's 3. There's a kink after 2, which means that there is 3 variables. You don't look at the component matrix, and here's the pattern matrix. So it shows you, here we go, component, it shows you that these 6 variables fit together, and these are called factor loadings, and they should be above 0.5, which shows you your convergent reliability, which is good. It shows you that the 6 effective variables fit together and they're all above 0.5, which means that it's good convergent reliability, and it shows you that the 6 behavioral values fit together. If you didn't design your questionnaire properly, these could be all over the show, and if they're not in alignment and there's no validity in your research instrument and your data, you can throw away your questionnaires. I've had students do 1,000 questionnaires and there was no validity. We threw them away. There's nothing you can do with them. And that's the importance of designing a proper research instrument. And that's the importance of doing a pre-test, because at that pre-test stage, you can capture data for 30 respondents and we can do this validity test and check that there is validity and reliability. Because if there is not, your data is worthless. So, but in this instance, it worked out perfectly. But maybe this could have been 0.4, and you could then decide, okay, we're going to exclude this one Likert scale item because it's bringing down the convergent reliability. And then you could rerun the test, and or they could find one variable is an outlier and a form in a 4th column. So you could then delete that one variable and rerun it, and then hopefully it works. So, and then we don't do this, and then this pattern matrix we would use to do as part of the validity. So what do we do with this data? Let me show you. First, you check the KMO is above 0.6 and the Bartlett is significant. So you say the KMO showed sampling adequacy, it was excellent at 905. The factorability was assessed by a Bartlett's test and it was significant. Communalities, we don't really report show how much variance is explained, with low values of 0.3 indicating it's not a good fit with other items, so such items may need to be discarded, but generally we more look at the pattern matrix. Secondly, we check at the total variance that all the agent values are above 0.1, and there's a kink or elbow should be retained. So the PCA produced 3 factors. You say the agent values were this, the sum was 57. So, and here you show the kink was between 4 or 5, so we retain the first 3 variables, and you report all of this data as is. You put in this in, here's the kink between 4 and 5, so you retain the first 3 variables. The pattern matrix, so you cut and paste all these variables. So generally, when you do it, you say, if you look at our pattern matrix, you're not seeing all the variables because you're limited at 0.4. But for your thesis, this just makes it easy to see. But afterwards, you can run the analysis again. You go dimension gradation, factor analysis, and we go to options, and then we don't click suppress small values, and we click continue, and you click OK. And then you'll see it gives you all the values in the pattern matrix, but you can see these are the variables that were above 0.5, and these are the variables above 0.5, and these are the variables above 0.5. So when you report on it, you just report on it like, and now you put in all your Likert scale items, and then you just block this in different colors to show you that these are your 3 constructs. Yeah, I just showed you how to do this. And now you report on all your variables. This table you'll see in every single article. So the mean values we created already. And standard deviations, I showed you the difference. The factor loadings, you just go in to, as I showed you, let's just go up to the one where we didn't. The factor loadings are these variables. So you just copy and paste these 6, and these 6. And you place them in this table here. There's your factor loadings. Okay, like that, and they should all be above 0.5. The Kronberg alpha we have already calculated, although, as I say, you should do this factor analysis right at the beginning, because when you, 0.862, 0.13, they're all above 0.7. How do you get the average variance extracted on Kronberg alpha for in SPSS? You can't. So I actually, with Dr. Corey Ace, we developed a little formula where it does it for you. And what you need to do is cut and paste the factor loadings for each factor in here, and it does the calculations for you. So just to illustrate that, if we cut and paste the factor loadings for cognitive, the 6 cognitive variables, and we paste it in this template and we put it under 1, and we go paste, and we can call this, we can just give this a name, we can call this cog, you know, and we delete this because there's 6 variables, we delete it, then it does everything for you. It calculates your average variance expectance and your composite reliability. Then we can do this for, and there's these such calculators as well. If you Google, you can search for these calculators where you can just put in your factor loadings and it does it for you. I don't know why we've got 5 variables. Oh, I think we, somewhere along the line, we deleted a variable. So there's only 5 here. But anyway, so we'll put in, oh, I don't know why this is, oh, it just says AA. It doesn't matter. So we put this under 2. It's not related. And it populates this. So we delete these 2. And then somewhere, I think when I was playing around, I deleted one. And we take these 6. And we put this in. I think we deleted it to increase the AVE value. We can test that. We can test it. But let's just quickly go back here and put in these 6 in row 3. And there it does all of these values for you. Okay, and you can see it's populating this already. But I'll show you that. So there it's giving you the AVE and the composite reliability values. I just want to go to the original 6 values I had here. Let's just export this file, export, and we'll just, so I can get those 6 values out. I want to see why we got rid of, I'll just call it factor analysis. We are nearly done, but this is really the nitty gritty. Export that. And we go to the factor analysis. And we really after the pattern matrix, and there were 6 variables for the year. But you see, this 533, I've got a feeling we deleted after running it through the validity. So let's just put in all, paste. And oh, I just need to drag this down to cut the formula. You see, so when we put this in, it calculated the AVE. With these 6 variables in, this average variance extractor was below 0.5. And that means that it needs to be above 0.5 for there to be, you could argue and say it's close to 5. But if we delete, you can see the weakest factors loading that's just above 5 is this one. So we decided to delete this value, and you could run the factor analysis again without it. And when you take that variable out, but then obviously when you run your reliability test, you would need to test it for 5 variables. It may go down a bit, but as long as it's 0.7, and when you create the group for effective, you would need to use the 5 variables. That's why you do this first. And then you can see the AVE goes up to 5.41, which is acceptable. So here's the average variance extracted, which is convergent reliabilities. They're above 0.5. Composite reliability is another test instead of, or the same as Kronberg alpha. They above 0.7. They're all above 0.8. So now you would include them in the table. There's your AVE values and your Kronberg alpha. And you do that for each, you'd put them in, and you'd see this table in just about every journal article. And now you display. So in the original data, there were 6 Likert scales, did not align to the 3 factors as 5 yeah, so I'm just saying you can force it to 3, yeah, right. And then so how do you report on this? So you would say that there were generally positive mean values which showed positive attitudes. You would say that do I actually give you how to report? Oh yeah, I don't actually talk about it per se, but you would report on that all the factor loadings and average variance extracteds were above 0.5, which displays good convergent reliability. All the Kronberg alpha and Kronberg composite reliability were above 0.7, which shows good reliability. And then lastly, you need to do a test for, so I've just showed you all of this reliability. Lastly, you need to do a discriminant validity test, and you do that by, if we go into this factor analysis, you need to copy and paste this last table here, this component correlation matrix. You just go copy, you go into the template, and you just cut and paste anywhere like this. Okay, let's just, okay, it's fussy. Won't let me cut and paste it in. Okay. Let me cut and paste you in there. Let's just factor analysis. There's 3 columns, oh, there's 4 columns. Copy 4 columns and 3 rows. So let's just go back into the validity. 2, 3, 4, 1, 2, 3. 3 rows, 4 columns. Hopefully it allows that. Yes. And now what you do is you just move these 2 values below this value, and you move this value below the 1. We only got 3 scales, so this, you don't need any of this. And what this is done is taking the square root of AVE, the square root of AVE of the first one, the square root of the effective, and the square root of the behavioral. You've taken the component correlation values here and you've put them below there. Instead of the ones, you've got the AVE, and these values should be less than each of these square roots, and this is called Fornau and Larker's formula. And if these values are greater than these component correlation values, it means that there is discriminant validity. So if we go into this, it's based on Fornau and Larker. You can just Google it, 1981 or 19, yeah, I think it's 1981. And the square root should be greater than the correlation values, and you can see, and this is how you'd report on it. You'd say the square root is greater. But if these values are greater than these values, that means your AV values are too low, and there's problems with discriminant validity. I'm not going to cover the regression alternative, and here's some references and resources that you can just look at to assist you. And yes, I think that was a lot to take in, but this was recorded, and so just with these stats, actually they were sufficient to do my doctoral thesis. I didn't use anything more than these stats, and in fact I didn't even have any hypothesis. I just had research questions. I didn't know much about that, so my doctoral thesis was just GLMs, the generalized linear models, and I did cross tabulations, and I didn't do any hypothesis, oddly enough. So what I've showed you is enough. If you had a hypothesis, you could do regression, and but obviously if you have a more advanced model, you could use structural equation modeling. But structural equation modeling, you need AMOS, or there's another one, PLS, smart PLS to do. Mostly the engineering use smart PLS. In my faculty, or our faculty, we mainly use AMOS, which I bought for myself, which CPUT doesn't provide you. And that's how you can do structural equation modeling, which is basically the same as regression, except it does all the regression at the same time in a model. Yeah, so yeah, that's how you do your statistics. I think you must be all brain dead, but that's why I've recorded it, so that if you're at this stage, you can then set up your SPSS, and then you can come back to this video. You can go to YouTube as well, and I've showed you how to write it up as well, and you can do your own statistics. Yeah, I'm not quite sure if you have any questions, if you're still awake, but yeah, it's very technical, but there you go. Any comments or questions? It's a lot. I know if you're not there and you haven't done the stats, but you can see how important this is that you set up your questionnaire correctly, because if your questionnaire results are not valid and they're not reliable, you can throw away your data. So I don't know who it was that was, I think he's gone, yeah, he's had to leave the meeting. It's important that you'd maybe do a pre-test of your questionnaire, get 30 questionnaires completed, set up your Excel sheet, capture your data, set up your SPSS data, and then do your reliability and validity tests to see that they're okay and they're not all mixed up. Because if they are, then that means you need to go and work on your questionnaire further and do another pre-test then and check that the reliability and validity results are fine. It doesn't matter if there's no significance in your results, because that's a finding in itself, but it does matter if your reliability and validity measures are not correct. Then, as I say, you can throw away your data. So you need to set up your research instrument correctly, and that feeds into your questions and everything. So by the time you finish your proposal, your questionnaire also needs to be finished. Because that has a major influence on your research questions and your hypothesis, which obviously is what you're trying to determine. So yeah, that's it. I'm going to stop recording, and I've recorded it twice by Teams and this other device.